Okay, so welcome back. So we're going to continue on with natural log and integration using the trig function. So if we look at example number 2 here, we want to look at the inside of the x to the fourth. Its derivative is on the outside, so that's kind of telling me that this is going to be my u right there. So when we use our u substitution, we get x to the fourth. Du is just 4x cubed dx, giving us dx is du over 4x cubed. If I rewrite this, we get a 4x cubed, the cosecant of u, du over 4x cubed, and these cancel out. What we're left with is the antiderivative of the cosecant of u. So this is going to be one of our new ones that we have to remember, and there it is. The cosecant becomes negative natural log of the cosecant of u plus the cotangent of u plus your constant. We just have to replace u. And what we wind up with, negative natural log of the cosecant of x to the fourth plus the cotangent of x to the fourth plus our constant of integration. And there's our answer. So let's take a look at some fun ones with trig. Now these aren't necessarily going to be our natural log, but some things we need to kind of know how to do. So I guess the first one is. So here we want to take, oh no, don't tell anybody I forgot my d theta. All right. So when we solve this one, of course, we can look at the theta squared. That's just theta cubed over 3 minus secant squared. Be careful, that is not our rule up here. This is just for secant. Remember, the derivative of tangent of theta is secant squared of theta. So the antiderivative is just going to give us the tangent of theta plus c1. Be careful, not everything is going to be natural log. Number 4 is a really good one. This one pops up every once in a while on the AP exam. So let's take a look here. It's asked us to integrate from 1 minus sine squared. I don't know this one right here, but what do I notice when I see this 1 minus sine squared? Anytime I see a trig function squared, I think Pythagorean. In this case, I know that sine squared of x plus cosine squared of x is 1. So I could rewrite this by subtracting the sine squared. And I get 1 minus sine squared is cosine squared. And that means I could replace it. This becomes the square root of cosine squared of x dx. Taking the square root of a square, we're just going to get cosine of x. And this I know the antiderivative. What function's derivative is cosine? Well, that's just sine of x. From 0 to pi over 2, use your FTC, we get f of pi over 2 minus f naught. So what is this? Sine of pi over 2 is 1, minus the sine of 0 is 0. So we just get 1 right there. Very easy to solve that. All right, for number 5 here, this is a good one right here to know how to do. So let's see here. To solve this one, I'm just going to start thinking what derivatives are. For example, the hint here I say is, what is the derivative of cotangent? Well, we should remember that hopefully a little bit. That is negative cosecant squared of x. Notice on the top, I have this cosecant squared of x. This is telling me to use u substitution because my derivative is on top. Here. Let's see if that works. That's my first inkling here. So if we try it, if I let u be the cotangent of x, tx, it's all kind of the same, I guess. Du is the negative cosecant squared of x dx, and dx becomes du over negative cosecant squared of x. If I replace this, we get cosecant squared of x over u du over negative cosecant squared of x. Those cancel like we want. Be careful. We're left with 1 over u. Don't forget the minus du. And that's our new rule. That's our natural log. So we get negative natural log of u, which is the cotangent of x, plus your constant of integration. And there's our final answer. So let's practice just a few more definite integrals here. For example, on number 6, this is kind of a fun one for us. I'm thinking U substitution here because I have something inside. That's my composite. We talked about that in the previous video. So if I let u equal 1 plus the natural log of x, take my derivative, we just get 1 over x dx, giving us dx is just x du. And that's nice. When I plug it in, I get my favorite, I get a good little pickup line here, u cubed over x times x du. And those cancel. And what I'm left with is just u cubed du. Now I'm going to change my bounds here. I'm going to go and change my bounds. When x is 1, u is 1 plus natural log of 1. So u is 1 plus the natural log of 1, which is just 1 because that's just 0. So my lower bound is 1. When x is e, u is 1 plus the natural log of e. Well, that's just 1 here, so that's 2. And this I can integrate. U to the 4th over 4, my power rule, 1 to 2, and I just use my FTC. Plug in the 2, we're going to get 16 over 4 minus 1 over 4. I don't know what that is. I'm cheating. It's 15 over 4 if you want to simplify that. So let's take a look at number 7. Go and try that one. I'll work on a 2. I let u equal the natural log of x. Du is just 1 over x dx. Dx is just x du. And if we solve this, we get u cubed over x du, x's cancel, and go ahead and change your bounds. Let's go and change our bounds here. When x is e, u is the natural log of e, which is 1. When x is et2 brute, u is the natural log of e squared, which is just 2. So our bounds go from 1 to 2. Integrating, we get u to the 4 over 4 from 1 to 2. And again, we just do our FTC. So we get plug in the 2, 16 over 4 minus 1 over 4. I'm beginning to see a pattern here. I don't think everything's 15 over 4. So, but very easy to do here. All right. Hope you enjoyed this video. Go on to my next video and we'll take a look at some more examples here, okay?